Okay, so for this video, our goal is to find the critical numbers of this function. And just to kind of recap the definition of critical numbers are going to be numbers where either f prime of x is equal to 0, or f prime of x is undefined. And it's very important to understand that the values are in the interval, or the domain. So we have to always make sure that we look at the domain as well whenever we find our values that are potentially critical. All right, so first step of this problem is to find its derivative, and in doing so, it is very helpful to write it using rational notation as well. So let's rewrite that as x plus 4 to the 1/3 power. And again, that's not f prime, that is f of x. So now when we find f prime of x, we need to use our product rule and our chain rule. So that's 1 times x plus 4 to the 1/3 power plus x times 1/3 x plus 4 to the negative 2/3 power times the derivative of x plus 4, which is 1. So that right there is our formula for our derivative. Next thing to do is rewrite it back in the original notation. So f prime of x is the cube root of x plus 4 plus x divided by 3 times the cube root of x plus 4 squared. Now, it should be very clear to us that when x is equal to negative 4, this derivative is undefined. And it's very important to understand that negative 4 is in the domain of the original function because the cube root of 0 is defined as 0, or just as 0, actually. So therefore, we know that x equals negative 4 is critical since f prime of negative 4 is undefined and x equals negative 4 is in the domain of our function f of x. Next thing to do is to find out when and if our derivative is equal to 0. So we're going to set f prime of x equal to 0 and solve for x and see what that gives us. So we're going to have the cube root of x plus 4 plus x divided by 3 times the cube root of x plus 4, and it doesn't matter where we put that square, is equal to 0. So first thing we'll do is we will multiply both sides of this by 3 times the cube root of x plus 4 squared. So 3 times cube root of x plus 4 squared on both sides. And very important to make sure that we distribute this quantity to both of the terms on the left-hand side. So when we multiply on the left-hand side, we're going to have our 3 as our coefficient. And then we're going to have the x plus 4 is to the 2/3 power. And then we're going to have the x plus 4 inside the parentheses as the 1/3 power. So that's really an x plus 4 to the first power. So we're just going to write it that way. For the second term, the denominator is going to cancel out with just plain x. And then on the right-hand side, of course, we still have 0. Multiplying this through and solving for x, we get 3x plus 12 plus an x is equal to 0. So 4x plus 12 is equal to 0. 4x is negative 12. So x is negative 3. And once again, if we look, negative 3 is definitely in our domain of our original function. And negative 3 is going to make our derivative equal to 0. So x equals negative 3 is a critical number. Since f prime of negative 3 is equal to 0, and x equals -3 is in the domain of our original function f of x. So again, we've got two different critical numbers for this function. One of the critical numbers comes from the derivative being undefined at the point x equals -4, and the other one comes from the function having a derivative that's equal to 0 at the point x equals -3.